Okay. So today we're going to do 2012 Scholarship Physics question number 4, motion. So we will start with part B because that explains what the question is. So the question is telling that a ball X is released from rest from a height h and it hits the ground with speed v ms minus 1 at precisely the same time as ball X is dropped. Ball Y is launched straight up from the ground at v ms minus 1. So this means that within the same time ball X is going down, ball Y would be coming up. So so if we're going to analyze the question, ball X is released from rest from a height h. So the fact that it tells that the ball is released from rest means the initial velocity of ball X is going to be 0 and G is going to be 9.8 ms minus 2 downwards. And so if we're going to talk about Y, ball Y is launched straight up from the ground at v ms minus 1 means the initial velocity of, we don't know the initial velocity, but like there's a, so if it's going to be launched upwards, that means there's an initial velocity given to it. And the final velocity of the ball will be 0 at the top. So when you launch it upwards and when it reaches upwards, at that point it's going to be 0. And again G is going to be 9.8 ms minus 2 downwards. So the question for us is to use physical principles to explain this result. So the first thing we're going to tell is that ball Y is given an initial velocity upwards. So if you're going to launch the ball upwards, you're going to give an initial velocity. And ball X is released, which means it has 0 initial velocity. So since it is released from a rest position, it has an initial velocity of 0, unlike ball Y. Ball Y would travel a greater distance compared to ball X. So why would this happen? This is because the initial velocity is given to ball Y, therefore it would travel a greater distance compared to the ball X, which has 0 initial velocity. So considering these few reasons, therefore the balls will meet at a distance greater than halfway for ball Y.